Hey everyone, this video is for lesson 3, which consists of constructing parallel lines as well as copying an angle to construct parallel lines. So we're going to start by what we did yesterday, and we're going to construct a line perpendicular to this line here, which is named line 1, and it's going to specifically pass through point A. So to recap yesterday, we said in order to create or construct perpendicular lines through a point not on a line, which this is not, first step is to do our smiley face. So needle on A, open up past that line, and create an arc so that it goes through that line into points. We then said once you have that arc in there, we have to indicate the 2 points of intersection, here and here. All right, and now we're going to do the perpendicular bisector of those of that segment. So we're going to take our compass and we're going to adjust it so that it is on one endpoint and more than halfway, and then only need to create arcs under the line. Since point A is at the external point, it's on the opposite side of the line. Go, and then we are going to connect. Excellent. And now what we've just done is we've created or we've constructed perpendicular lines. So I know that these lines are perpendicular, and I can put a little box here to show that. And that was really how yesterday's lesson was summarized, right? You smile through the line, and then you do the perpendicular bisector of the segment of where the arc intersects the line. So we're going to build off of this construction. And you can take a look at the next slide. And basically, yesterday we learned how to construct perpendicular lines. We're going to use this construction only and somehow construct parallel lines. So we're going to use perpendicular lines to construct parallel lines, which is going to be interesting. And the lines that are going to be parallel at the end will be labeled line 1 and line 2. Now, we constructed a perpendicular line to line 1 from point A. That's what we just did in the do now. We're going to actually label that line, line 3. So let's go back here. We actually did step 1. I'm going to go back here, and I'm going to now label this. I'm going to label this line that's perpendicular to line 1, and I'm going to label it line 3. All right, now we need line 2 to be parallel to line 1. So first, what does it mean for lines to be parallel? And in life, where have you seen parallel lines? Often, students think of railroad tracks, right? When I think of railroad tracks, I think of the tracks that run side by side, right? They don't cross, they don't touch, which is true in 2 dimensions. We say that lines are parallel when they have the same slope, right? Both of these lines have the same slope, which is why they run parallel to each other. So I need a line parallel to line 1. So in my mind, I'm like, well, that's easy. If line 1 is horizontal, line 2, if it's parallel, has to be horizontal too. Can't I just draw it in? And the answer is no, you can't just draw it in. But I know my line has to look something like this, and it has to go through point A. But wait a second. This line that I just drew in is also perpendicular to this line here. So what we're going to do is we're going to do what we did yesterday. We are now going to construct a line perpendicular to line 3 through point A. So we did that yesterday. We're going to smile through the line again. So let's kind of adjust our compass. Remember yesterday when the point was on the line, put the needle on the center, on the point. And now you just kind of smile through the line. So do an arc here and an arc here. Okay. Now I have my 2 points. My points are where the arc and the line cross. So here and here. And now I'm going to do the perpendicular bisector of the segment. So I go to this point of intersection, more than halfway. Since the point is on the line, I need to make arcs above. That's a little big. I'm going to make arcs above and below. left and right, flip around, go to the other endpoint, arc here, and arc here. Take my straight edge, connect through, as so. Excellent. It's a line, so we should have arrows. And it says to label this line, line 2, so line 2. So we have line 1 is now parallel to line 2. But more importantly, although they're parallel, what we actually just constructed was that line 2 and line 3 are perpendicular. Right? So I constructed really 2 perpendicular lines, which in the end gave me 2 parallel lines. Now, we can show that lines are perpendicular by putting little boxes. You can show lines are parallel by putting arrows on the lines that are parallel, as so. So off to the side, let's make some statements. What did we first do? We first constructed line 1 perpendicular to line 3. Then we constructed line 3 perpendicular to line 2, which then gave us line 2 parallel, look at that new symbol, to line 1. And there we have it. If you notice, 1 and 2 are both perpendicular to 3, which then makes them parallel. So 2 lines, I'll actually type this out for you. Interesting little fact. 2 lines perpendicular to the same line are parallel. And you show parallel by lines that are like on a slant. Get this shortened up. Excellent. And here we have it. And that is how you can construct parallel lines. Remember perpendicular, the symbol for perpendicular is that upside down T. Perpendicular. Parallel are those slash marks. You show that lines are parallel by putting arrows. You show that lines are perpendicular by putting that little box. Okay, so let's take a look. We did this. Done. Perfect. Let's take a look at our steps. So first thing that we did is we constructed a line perpendicular through the given point, not on the line. That was the first one. So we used point A and we did our smiley face in the perpendicular bisector. Then we did the line perpendicular again, except we changed it. The point was on the line. So the same construction, first the point was not on the line, then the point was on the line. In the end, our lines were parallel. So 2 perpendicular lines, so 2 lines perpendicular to the same line wind up being parallel. The notation for parallel over here, those little slanty lines, or even sometimes you'll see them straight up and down. Okay, remember this is a video, so you can stop, you can rewind, pause, use this video however you need to. If you'd like, you can rewind back and rewatch how I just did this now given these 2 steps. But we're actually going to practice one more time. So here it is. So construct a line parallel to the given line, so a line parallel to this line through this point. So it's going to look like another line that's horizontal through this point. So remember, I'm doing the perpendicular line construction 2 times. So let's walk through it together. Okay, first, take my compass. Point's kind of big, so make sure you try to get right to the middle. Smile through the line. So smile through the line. Excellent. Now we're going to put 2 points where they intersect, here and here. Fabulous. Perpendicular bisector construction. Use those endpoints, go more than halfway. Only needed arcs below because our point is on the other side of the line. Great. Get the lines perpendicular by going through the arcs and through that point. You want to get in the habit, and I've said this numerous times now, make sure that line, when you draw it in, goes way past the point. It's also a line, so it needs arrows. So we have an arrow here and an arrow here. Okay, so now these two lines are perpendicular. So now I'm going to create and construct another line that's perpendicular to this line through this point. So I do that by needle on the point, and I need my smiley face. So arc here and arc here. If it makes it easier, turn the page, right? Have this be horizontal. That's fine. And then we need 2 points. The point is here and the point is here. Now we're going to do the perpendicular bisector of this segment. So go to one endpoint, open up more than halfway. We need arcs on both sides since the point is on the line. Flip it around, go to the other endpoint, arc, and arc. If you notice here, my arc's just about cross. So it's why we always make the arcs a tad bit longer the first time so that you can make sure you get an intersection. Connect through now. All right, just fix this a little bit like this. Excellent. So put arrows at the end. This is a line. And now this line and this line are perpendicular. But in the end, these two lines are perpendicular to the one that's going up and down, this vertical line, which then means that these lines are parallel to each other. And I show that by putting these little arrows. And there you have it. Okay, so that was practice with constructing parallel lines using the perpendicular line construction. Now we're going to walk you through how to copy an angle and how to use this construction in constructing parallel lines. So let's start by copying an angle. So what does it mean to copy an angle? Well, copying an angle is like copying a segment, except it's not a segment, it's an angle. But at the end of the day, when you copy anything, you're going to need intersection points. You're going to have to show a duplication of this angle. So whatever I do to my original angle, I have to also do as I walk through my steps. So let's start like we start copying a segment. We're going to draw a ray. So I'm going to put a point. There it is. And I'm going to draw a ray. So remember, a ray, arrow at the end. Now, when I drew my ray and I put a point, I have to label this. This is going to be A prime. We're making a copy. Okay. So think about it. When I copied a segment, I needed an arc. So when I copy an angle, I also need an arc. The only way I get an arc is by placing my needle at the vertex of the angle, so like the corner of the angle, and I open it up a given width. You don't have to open it up to the end, right? Because an angle really doesn't have an end if there's arrows at the end. An angle is actually composed of two rays that share a common vertex. So I'm going to open up, I usually go kind of midway, and I'm going to swing an arc that goes through both sides of my angle. Now, if I'm copying this, what I just did here, I have to do down here. And I want the arc to be the same size, right? Making an arc that's this tiny now wouldn't make sense. It has to be the same size. So I'm going to make it like this. If anything, I want to make it even a little bit bigger. So I'm going to keep it like this. All right, excellent. So why did I draw this arc over here? Well, once I drew the arc, what happened? I got 2 points of intersection, right? I have a point of intersection here and here. On my new ray, I only have 1 point of intersection. I have to figure out where this other point of intersection is. So to do that, I'm going to use my compass to measure, right? We said that in the beginning of this class. You're going to use your compass to measure a lot. Here it is. I'm going to use my compass to measure the distance from here to here, these intersection points. Perfect. Show that you measured by swinging a tiny arc. And now bring this down to your new ray at the only point of intersection that you currently have, which is here. And voila. To finish this, I have to create the other side of my angle. So I go through the vertex, through the intersection. And there it is. We just copied an angle. That's so. Okay. One thing is that instead of actually writing out angles, sometimes you'll see like this less than symbol. I know sometimes I do it like this, like a little arc through it. Those both mean angles. Okay, so that's a symbol notation. All right, so there were the steps, right? First we drew a ray, then we drew an arc on the angle, and the same arc down on our ray. We measured the intersections of the arc and the original angle. And then you put the needle on the intersection of the arc and the ray, you swung an arc. And then finally, you just use your straight edge to connect the vertex to the points of intersection to form the actual angle. We are going to practice it again. Let's practice copying angle A. So what did we do first? We started with a ray. So I'm going to put my point. I'm going to create a ray. And since I'm copying angle A, it can't be A. I'm going to call it A prime. It's fine to call it A prime because it's on a different page. So A prime has a unique location now. Okay, first step. Remember, we're copying, we need intersections. So take my compass, needle on A, the vertex, open it up, decent width, not too small, not too big. Swing an arc so it goes through both sides of your angle. You're copying, so do the same exact thing down at A prime in that ray. Make the arc about the same size. Go back to your original now, your original angle. And let's put 2 points of intersection here and here. We only have 1 point on our ray. So we're going to take our compass and we are going to measure now the points of intersection here and here. Show you've measured by swinging an arc. Take that same measurement, don't change the compass width, bring it down to your new ray, swing an intersection arc, and now connect from your vertex through the intersection of your arcs. And there it is. Now we just copied 2 acute angles, right? We can do this even if the angle is obtuse. Let's take a look at angle B. Let's copy angle B the same exact way. So I'm going to now start with a ray. I'm going to label this B prime. Take my straight edge, get that right in there. Excellent. Take my compass, because the whole purpose now is to ensure that we have some intersections. So take my compass, bring it up to this vertex. Now it's a little awkward because now I have to measure from this side of the angle all the way to the other side. Look how much larger that arc is. That same arc has to be down here at B prime in the ray. So make the arc really big. There it is. Okay. Now we said we drew an arc up here to get 2 points of intersection. So your points of intersection are now here and here. All right. Let's take our compass and we are going to measure those points of intersection here to here. Okay, you show that you've measured by swinging a tiny arc. Done. Bring this down now to your other point of intersection down here at B prime and swing a tiny arc. There it is. Finish it by connecting the vertex B prime through the intersection of those arcs. Excellent. And you've just copied now angle B down to B prime. Okay. Again, this is a video. You need to go back and you could watch me copy B down to B prime again. Now, let's use this construction. So the exact construction, we're going to copy an angle and we're going to construct parallel lines, but we're going to copy an angle. So let's think about this. How can I copy an angle if I don't actually have an angle? You might be thinking I made a mistake. I didn't. The first step here is we actually have to create an angle. So the way you do that is you're going to take your straight edge and you're going to make an angle. You're going to take your straight edge, you're going to go through the point and have it intersect the line. Now we've just created this angle over here. That's the angle that we're actually going to be copying. So let's copy this angle here, up at this point over here. We're going to start not by creating a ray, because the ray essentially is already there. We're going to start by making our arc. So I'm going to open this up, and I have to go through both sides of my angle, here and here. Here's the vertex. I know the vertex of my new angle is already over here. So I'm going to now take my compass, and I'm going to swing an arc of about the same size. Here we have it. Okay, next step. Remember, we have to figure out where are the intersection points. So our intersection points on our angle are here and here. On our new angle, I only have one intersection point here. So let's take our compass and measure the intersection points of the angle down here. You have to adjust the compass, right? You're going to have to adjust the compass. So you've measured by swinging an arc. Now slide that up this line and stop right at the other intersection point. Swing another arc. Perfect. Now connect the vertex through the arc with your straight edge. Except you don't want to do it like this, right? There are lines that are parallel, so you actually want to go through that point like that. Excellent. These are lines, so let's add our arrows. And I actually just copied this angle. And since I copied that angle, my lines are parallel. Later in this unit, we'll talk about why these lines are parallel. This justifies that the corresponding angles are congruent. Again, this will be later in our class, but we will come back to this construction later on. All right, so let's see the steps that we did. First, we started by drawing a line through the given point and the line. We created the angle here. Right? You need step 1 to actually create the angle. Maybe I'll put that here. This step, you have to actually create the angle. Okay, now you do the construction for copying an angle, but you're using the point as the vertex. And once you did that, once you copied the angle using that point as the vertex, you got parallel lines. And here it is. All right. So that was how to copy an angle to get parallel lines. So we would like you to kind of decide how you would like to get parallel lines here. Do you want to copy an angle? Or maybe you want to construct perpendicular lines to get lines that are parallel. What I'm going to ask is that you pick one and then you try it. I'm going to do this by copying the angle, and you can definitely watch if you decide to copy the angle. If you decide to do perpendicular lines, you can kind of go back here and rewind and watch me do this construction. But I'm just going to walk through this one more time. So to copy the angle in order to get parallel lines, first thing that I need to do is I need to actually create my angle by drawing in a line that goes through the point and the line. Then I needed to take my compass, and I need to now create my first arc at this vertex down here. So open this up, swing an arc that goes through both sides of my angle. Go up to R, swing the same size arc. Perfect. Now I have intersection points. My intersection points are here and here. I only have one intersection point on my new angle. So I'm going to go back, going to measure from this intersection, adjust and measure here, swing a tiny arc, slide my compass up this line and stop where the arc meets the line, swing a tiny arc. And now since the lines are going to be parallel, take my straight edge, and although I'm copying an angle, I want to create a whole line. Put arrows at the end. And now I know that this line is parallel to this line down here. And you're done. Okay? That finishes up how to copy an angle as well as construct parallel lines using either the perpendicular line construction or copy and angle construction. Again, this is a video. Feel free to go back, rewatch any aspect of this video. It is a little long, so it might take you some time to actually practice both constructions. If you have any questions, reach out through email or Google Classroom.